All right. Today, we are diving deep into one of the most important concepts in AI right now, the context window. It's the magic behind how an AI can remember things, how it reasons, and, how it sometimes gets things completely and utterly wrong.
You know, if you go back to just 2020, it feels like a lifetime ago in AI years. Back then, an AI's memory was, well, tiny. It was like trying to read a whole book by looking at it through a little keyhole. You could maybe see a few pages, enough to fix a small bug or answer a simple question, but that was pretty much it.
Okay, now fast forward to today. That little keyhole, it's been blown wide open. We're talking panoramic, floor-to-ceiling windows. We've gone from a few pages to being able to process an entire library of information at once. I mean, some of these models can hold a whole company's code base in their working memory. The jump has been absolutely massive.
And that right there is the big puzzle we're here to solve today. If these AIs have this incredible photographic memory for a whole library, why do they still forget what was on page 250? How can they get so confused sometimes? It just doesn't seem to add up.
So, to really get to the bottom of this, we first have to understand the journey we've been on. This whole thing with context windows isn't just a simple upgrade. It's been a total revolution in how AI even sees the world.
So what even is a context window? The easiest way to think about it is like the AI's short-term memory. It's the mental scratch pad where it holds everything for the current conversation. That includes your question, any files you've given it, and its own response. And we measure the size of this workspace in tokens, which are basically just words or pieces of words.
And the growth here, it's been just explosive. In 2020, GPT-3 had about 4,000 tokens. You could fit a decent short story in there. Now, we're looking at models like Gemini with over 10 million tokens. That's not just a short story anymore. That's the entire history of a company's software. It's a staggering leap. But here's where the story takes a sharp turn. Right as we were celebrating these gigantic memory capacities, people on the inside started saying, hang on a second. The feeling started to grow that maybe, just maybe, this race for bigger and bigger context was actually solving the wrong problem. And that brings us to this really fascinating kind of counterintuitive issue. Turns out, having a massive memory doesn't actually mean you're good at using it. In fact, for an AI, sometimes throwing more information at it just makes things worse.
This is a super important distinction to understand. There's capacity, that's the big flashy number on the box. It's how much stuff you can cram into the model's memory. But then there's utilization, and that's what really matters. That's how much of that information the AI can actually find and use to get you the right answer. And spoiler alert, those two numbers are not the same at all.
You can see this perfectly with something called the needle in a haystack test. Researchers take one specific fact, the needle, and they hide it somewhere in a huge pile of text, the haystack. Now, if that needle is right at the beginning or right at the end, the AI finds it almost every time. But what happens if you bury that fact deep in the middle? Whoops, the accuracy just tanks. The AI literally gets lost in the middle.
And it's not just about accuracy. Trying to brute force a problem with 1 million tokens has some really painful real-world costs. Your response times can crawl to a minute or more. It gets insanely expensive because you're paying to reread that massive haystack every single time you ask a question. And you're just drowning the important information, the signal, in a sea of noise.
So, if bigger isn't better, what's the solution? Well, this is where we get to the really exciting part. This is the new frontier, the skill that is defining what high-quality AI looks like in 2026, context engineering.
We've all gotten used to the idea of prompt engineering, right? The art of crafting that perfect question to get the AI to do what you want. That was the game for the last couple of years. But things have moved on. The focus now isn't just on the question you ask, but on the entire information environment that the AI lives in. It's the difference between writing a perfect sentence and designing a perfect library. So here's the bottom line. A context engineer does way more than just write prompts. They are the architects of the AI's world. They build the systems that feed the AI exactly the right information at the right time. It's all about quality, not quantity. They're basically putting the AI on a healthy information diet.
Okay, so how do they actually do it? Let's pop the hood and take a look at the toolkit. These are the practical, hands-on strategies that a context engineer uses to build these smarter, way more efficient AI systems. The absolute cornerstone of this whole approach is a technique called retrieval augmented generation, or just RAG.
The idea is so simple but so powerful. Instead of making the AI read the entire library every time, you first use a really smart search system. Think of it like a librarian to find the one exact page you need. Then you just hand that single, super relevant page to the AI. It's about working smarter, not harder.
And the results? I mean, just look at this. It's not even a contest. A query that would cost you over $50 and take up to a minute using the brute force method costs around $2 and takes 1 second with RAG. And on top of that, your accuracy is higher, and you get perfect citations, so you know exactly where the answer came from. It's a win across the board.
And RAG is really just the beginning. The pro context engineers have a whole toolbox of other tricks. They build systems that can intelligently choose which files to load, create different kinds of memory for the AI, and even use things like knowledge graphs, so the AI understands not just words, but the relationships between ideas.
Okay, so managing data inside the system is one thing. But for AIs to be really, truly useful, they need to connect to the outside world, to all the other apps and tools we use every day. And that brings us to the final piece of this puzzle.
And that's where something called the Model Context Protocol, or MCP, comes into play. You can think of it as a universal adapter for AI. It's like the USB port for AI tools. Before this, connecting an AI to a new app was a huge pain. Every single one needed a custom-built connection. MCP creates one single standard so that any AI can talk to any tool right out of the box.
In the real world, this is an absolute game changer. It means your AI can manage your GitHub projects, run automations in Slack, or pull data from a database for you, all just by having a normal conversation. It's seamless because everything is finally speaking the same language.
So, how should you pick an AI model in 2026? You stop looking at that one big context size number, and you start thinking like a context engineer. You ask, what's the right tool for this specific job? GPT-5 is your reliable day-to-day workhorse. Claude 4 is what you bring in for those heavy-duty, complex coding tasks. And that giant 10 million token Gemini, you use it strategically, maybe once to get the big picture map of a new codebase, and then you switch to smaller, faster tools to do the actual work.
And that really brings us to the golden rule for 2026. This is the big takeaway. Use a large context window to reason about the evidence you give it, but use smart retrieval techniques, like RAG, to decide what that evidence should be in the first place. It's all about giving the AI clarity, not just cramming in more capacity.
So, I'll leave you with the question to mull over for your own work. Is your AI's biggest problem really about what it can see, or is the real challenge about what it can find? Because the answer to that question is the secret to building truly intelligent systems now and in the future.